Hi everybody, welcome back. Today I'm going to do a review with you guys because next Monday is the day of our math test. So for this test we are going to be tested on the rational exponent and the exponent equation. I believe it was exponential equation, yes it was that. So let's first talk about the rational exponents. So we have to first exploring the exponent first. So we have the first exponent 2, explore that, and then we explore the exponent 1 over 2. For the exponent 2, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. So in its reciprocal, it's 1 in the power of 1 over 2 is 1, 4 in the 1 over 2 is power of 1 over 2 is 2, 9 in the power of 1 over 2 is 3, 16 in the 1 over 2 is 4, 25 in the 1 over power of 1 over 2 is 5, 36 in the power of 1 over 2 is 6, 49 in the power of 1 over 2 is 7, which means I would say this is the square root. So when it's in the power of a fraction, it's always a root, power root, I would say. Exponent 3 and the exponent 1 over 3. So 1 in the power of 3 is 1, I would say 1 cube is 1. 2 cube is 8. 3 cube is 27. 4 cube is 64. The 5 cube is 125. 6 cube is 216. The 7 cube is 343. So 1 in the power of 1 over 3 is 1. 8 in the power of 1 over 3, I would say cube root of 8 is 2. The cube root of 27, which is 27 in the power of 1 over 3 is 3. Cube root of 64, I would say it's 64 in the power of 1 over 3 is 4. 125 in the power of 1 over 3, I would say cube root of 1 over 25 is 5. With the 216 in the power of 1 over 3, I would say the cube root of 216 is 6. The cube root of 343 is 7. So this one I would say is the cube root. If you think I'm talking too quick, I can slow it down. So as I'm comparing the entry with first and second column of each table, I would say the first table is a relationship between the square and the square root. The table 2 is relationship between cube and the cube root. Yep, I believe it's that. So let's use some of the examples. I'll grab my calculators because some of them I need to use the calculators. So for this one, I would say square root of 25 is in the power of 5. So the cube root of negative 125 will be the negative 5. But let me see if I'm doing it correctly because I don't want to blame any of you guys. So for this two of them, I feel like I'm correctly. So the square root of 1 over 81. Sorry guys, it's 81 in the power of 1 over 2. Yep, it is square root of 81. It's 9. So let me give you guys some practice. So square root of 64 is 8, just like this. I'm doing correctly. So 1.2 and square root is 1.1. So for the calculator, if you want to do the cube root, so all we have to do is to press a shift and then press the x power. It's gonna be this thing, the power root. If I put in the power 3, it's cube root. And then I would type in 1, 2, 16, and then there would say 6. Yeah. So remember to bring your own calculator to the test on Monday, because if you didn't bring it, Mr. Maroda will get you one. And you might not know how to use that calculator, right, guys? So for this one, 36 in the power of 1 over 2 is same as square root of 26. Sorry, 36. 6. So I will explore with you guys about the homework. For homework, I will get you guys some questions because I don't want to show you some of the wrong things. So the square root of 144 is 12. The cube root of 64 is 4. So as you know, the negative exponent, the number 2, I still said that we can't solve them with a negative number. I don't know why. I don't know what's happening. Is it because Miss Soka is an elephant? Negative 16 square root is negative 4. So for the cube root of negative 347 is negative 7. So for the evaluation of the cube root, so for the power 4 root of 25, so I will do that. Shift power root, first between 4 and then 25. So what I got was 2.236, but if I'm rounding it to 2 decimals, I'll round it to 2.24. For cube root of 30, I got 3.107232506, but since some questions make me round to 2 decimals, I will round to 3.11. Sorry, 3.11. Like that. So her 91 is 9.53. 9, if I run to 2 decimal, I'll run to 9.54. Let me see. Yep, I see the question. Yes, I nearly made a mistake. So this time I'm a pig. So cube root of 8 is 2. Oh, the cube root, I found a new way for the cube root. I can either do this, and then the cube root just do this. This. Alright. Now I'm gonna tell you guys some of the examples that I did that are successful. So for example, we have to find the volume based on the surface area. So this formula that we did level, calculate the volume cube root with a surface of 15 centimeters square. So as you said, as equals to exact square, what we have to do is volume equals to 50 divided by 6, where we get the volume and then the power 3 over 2. So what we have to do, 50 divided by 6 and the power of 3 over 2. So 24.1 cm cube. So like that. For the future value, I don't know how can I do this. So for this one, I believe the A equals to present value. So as we know, they said that A equals to P equals to 1.IN. So for the future value, like this. So the future value is 1000. No, so a equals to so a equals to, so future value is a. So future value is 1000. So how can you get the present value? P equals to 1000 times 500 minus 1 square. No, a base to the power 6 divided by 2, like that. So I 10a. So it will be 10. Oh, some questions are hard, so I understand. So let's forgive me like this. So initial deposit. So how can I do initial rate? So initial deposit. So I equals to pressure. The amount of deposit. So initial equals to future value is 1000 divided by 500. And then the 1/6. So 1000 divided by 500. So and then the times 1/6. So it's 12.2%. Same question. It's similar. 1000 divided by 500. The power of 1/6, 1/8. So it's to 0.091, which is 9.1%. Like this. I don't know why it's 0.091, but I would say 109.1%. So if you did a 9.1%, it means Miss Soka is an elephant. So I did the exponential equations. So as the exponential equation is an equation that contains a variable in the exponent. Some exponential equations can be solved without technology by writing both sides of the equation power of the same base. So example, as for x and 4 in power 3 is both power 4, so exponent must be equal. So 4 in the power cube equals 4 3 is x equals to 3. So let me give you an example. 5 power x to the power in the power 6 is x equals 6. So let me give you guys a harder example. So 3 in the power 5x plus 8 equals to 3x 3 times 3 cube power of x. So I would say 3 in the power of 5x plus 8 equals to 3 in the power of 3x. So 5x plus 8 equals to 3x. 2x to the negative 8, x to the negative 4. So the third example is that tc equals tm. 81 times 3 in the power 2 negative 2t equals to 27 times 3 in the power negative 1. 3 in the power 4 times 3 in the power negative 2t equals 3 in the power 3 times 3 in the power negative 1. So 3 in the power 4 minus 2t equals 3 in the power of 2, 4 minus 2t equals to 2. S equals 2t equals to negative 2, negative 2 is negative 2, t equals to 1. So for this one, the planning department of a township is responsible for estimating number of utility hooks up the new subdivisions. Currently, it's about 729 hooks up per year. Activity lookup given by d equals 27 power 3n. So active demand when n is since year 2017, how to determine when the demand reaches the capacity. So for this one, d is 7 per year. So this one's going to be, so d as we first start, d equals to 27 times 3n, 3 to the power 3 to the power n. So 17. So 3. So 700. So the d is 3 in the power 6 equals to so 3 times 3 and 3 and equals to 3. So it be 3 years. So this one is 100. So let's name bacteria doubles every hour, taking its own bacteria. He used the equation of b with 100 times 2t to the power b of t hours. So in the power t. So t equals to 6. So I feel like, let me explain to you guys the sum of those. So 10 in the power x minus 3 equals to negative 2. So x minus 7 to negative 2, x equals to 2, negative 2 plus 3 is 1. So I feel like we are done for this. So I hope you enjoyed this lesson. If you like this video, please subscribe to me. But last but not least, wish you guys good luck in the test. We have to do a good job in the math test to prove that Miss Soka is an elephant.